Up until this point, we've been looking at some very specific examples of optimization, but I think we're ready now to try and generalize the patterns that we've seen thus far. So we're going to look at general optimization. And in general, we know that any min-max point will be when the derivative is 0. So even if I have a situation we might not be as familiar with, we know the minimum, maximum, optimal point will be when that derivative is 0. For example, after I take some medicine, that drug concentration is given by C of t, the concentration over time, is equal to 0.8 t over t squared plus 57. That tells me the concentration of the drug in my bloodstream. We want to know, when is it at a maximum? Well, if I want to find the maximum, we just have to take the derivative of the concentration with respect to t. This is a quotient. We know the quotient rule. We take the derivative of the top, which is 0.8, and we multiply by the bottom, which is t squared plus 57. Subtract the derivative of the bottom, which is 2t, times the top, which is 0.8t. And then we divide by the denominator squared, which is t squared plus 57 squared. We know the maximum is going to occur when that derivative is equal to 0. To clear the fraction, I'm going to multiply both sides by that denominator of t squared plus 57 squared, because then it reduces out of the left side, and 0 times anything is 0. On the right side, we have 0. On the left side, I'm going to go ahead and distribute things through. So I get 0.8 t squared plus 57 times 0.8 is 45.6 minus 2 times 0.8 is 1.6 t squared. And then I'm going to combine like terms. 0.8 minus 1.6 is negative 0.8 t squared plus 45.6 is equal to 0. We can solve this then. I'm going to add the 0.8 t squared to both sides, giving us 45.6 equals 0.8 t squared. Dividing both sides by 0.8, t squared is going to equal 57. And then take the square root of both sides. T is equal to plus or minus, but we don't really have negative time because it's not going to be in the past before you took the pill, 7.55. And if the time is in hours, we would say in 7.55 hours, the drug concentration is at its maximum. Let's take a look at one more example before we wrap up. Let's just find two numbers whose product is 200, and the sum of the first and twice the second is as small as possible. Well, let's break this down into the pieces we know. We have two numbers. We'll call them x and y. And their product is 200. Product means we're multiplying together. So x times y equals 200. The sum, that means we're adding the first number, which is x, and twice the second. Twice the second would be 2 times the second of y. That's what we want to get as small as possible. We want to minimize that. The problem is we have two variables, but we can fix that really easy by solving the equation on the left for one of our variables. Let's go ahead and divide both sides by x so that we know y is 200 over x. That's what we're going to replace the y with. So x plus 2 times 200 over x. That's going to be x plus 400 over x. Well, if we're going to take the derivative of that, let's write that as 400 times x to the negative 1 power, so it's easier to take the derivative of. Because the derivative is where that minimum value is going to occur. The derivative with respect to x is equal to 1 minus 400 x to the negative 2. Well, 1 minus 400 x to the negative 2. Let's bring that negative 2 down to the denominator and set that equal to 0. That's what we want to solve. Adding the fraction to both sides, we get 1 is equal to 400 divided by x squared. Multiply both sides by x squared, and x squared is equal to 400. Take the square root of both sides, and x is equal to 20. Now, it could have been negative 20. It didn't specify in this problem, so negative 20 would also be a possibility. But let's pretend we wanted just all positive numbers. So if x is 20, we still need to find y. And the place we're going to get y from is that y is equal to 200 divided by our x. 200 divided by 20 is 10. So the two numbers that we need are 10 and 20. Those are two numbers whose product is 200. And the sum of the first and twice the second is as small as it possibly could be. That's how optimization works. We get an equation in one variable so that we can take the derivative and set that derivative equal to 0. That's where the maximum or the minimum will always occur. It's your turn to practice some of these. Take a look at the homework and let your instructor know if you have any questions.